Thank you. I work for MongoDB in New York. I've been involved with maintaining a number of libraries over the course of many years and seen them change and improve a lot. I've learned a ton by being involved in that process, and I want to offer you a shortcut for learning some of that. I'm going to go very fast. This talk is too long. So rest assured that at the end I will share a link to a blog post that will, you can read it at your own leisure. So imagine that you are a deity. Feels great, right? You have all this power. And you are in charge of designing the body for a creature. And as you think of ways that the creature can improve and evolve and be better adapted to its environment, you want to add those things to the creature's body, right? It would appreciate it. It shouldn't be stuck in the same body forever. But at the same time, you can't just go adding scales or wings willy-nilly. As a responsible designer of a creature, you are in charge of making sure that it is prepared for any changes that you make in its body. And the same goes for responsible library maintainers. We have a lot of promises to keep to our users. We have to fix bugs, add features, sometimes delete features if that's what's appropriate for the library's future development. But we can't violate the expectations of user code that relies on our library the way it works now. So how do we fulfill all of those goals at the same time? That's what a responsible creator does. So first of all, you should definitely add useful features. If you want your library to have wings so it can fly, you should add them. But adding features comes with a risk. We're going to look at an example in the Python standard library where somebody thought a feature was a good idea, and it turned out not to be. So, yes, you should add features. That's what I meant to say. Yay. All right. So in Python, there's these datetime.time objects, and they've got a Boolean conversion. If you've got a time that's equal to 9:30 in the morning, and you convert it to a bool, that's true. Now, what about 00? What about midnight? Its Boolean value is false. And I've been programming Python for more than 10 years. I didn't know this. You can imagine how this would bite people. If you are writing a calendar application, for example, let's say you have a function which can create an event, and the event can have it always has a date, but it optionally has a start and end. But it doesn't make sense to have an end time but no start time, so you have a check there for that condition. You can see where this might go wrong. If the coven meets at midnight, that's false, and that triggers the exception when it shouldn't. Now, you can correctly code this, of course. You can say end time is not none and start time is none, and that'll work, but that's subtle. So if you were designing a library intended to bite people, then this would be a good quirk to add. But you and I want to write libraries that are easy to use correctly. So it took years of painful debate and change, but eventually in Python 3.5, all times that are not none are now true. But this makes me nervous too, because what about library authors who actually knew about that quirk and were relying on that? Really, the best thing of all to do is not to add bad features in the first place. So this is the first of the 10 covenants that I'm going to describe that a creator deity has with its creature, is don't add bad features. Now, I don't want to be too critical because this bad feature had been implemented by Tim Peters, who is a founding programmer of Python. It was way back in 2002 when he first implemented the datetime module. Even founding programmers can make mistakes. You and I can learn from this lesson. We can avoid adding bad features by just adding few features, so this is the second of the 10 covenants, is don't add a feature, don't add a method or parameter or function without a good reason. You know, features are kind of like children, right? It only takes a moment, you're enthusiastic, but you have to support them for years. Think twice. Now let's say that you do decide to add a feature. One of the questions is, what is the right feature for the job? Let's look at another example from the Python standard library. So you probably know that in Python 3 you can define a coroutine with async def, and this creates a coroutine function, and then executing it provides a coroutine object. So if you print this thing, that's what you get. A common mistake to make is to forget to await this thing at all, so it never actually runs. And once it's garbage collected, it's gone for good. So the asyncio implementers wanted to make like a debug mode for asyncio, where if a coroutine was garbage collected but you never awaited it, it would print a useful warning. Yuri Selivanov implemented this, and the kind of foundation for his debug mode feature was a wrapper that could take in a coroutine and return something else that would have like a warning attached to it. So a coroutine wrapper is a function that takes in a coroutine and can return anything at all, and you can install it globally with this set coroutine wrapper. So if I want to do this, I could make a coroutine wrapper that just returns hi. And once this has run, then this code that you saw before, now it no longer prints a coroutine object, it prints hi. This is one hell of a hook. This changes the very meaning of the async def syntax. Nathaniel Smith criticized this on the bug tracker. He said that sys coroutine wrapper is a problematic API. It was added to solve a specific problem to track where coroutine objects are created so the warning they print can include a traceback. But to do this, it adds a very generic hook to replace all instances of a built-in type with an arbitrary new type. And this feature had to be deleted. So we can learn from this mistake and avoid it ourselves by keeping features narrow, shaping them to the problem we are trying to solve. Nathaniel's replacement for this is much narrower. It just sets the tracking depth for this traceback that a coroutine prints out if it dies without ever being run. So now you can see that the coroutine is still a coroutine object, but it prints this nice warning with the line number that you need to look at to fix your code. So this is great. This solves the problem without like changing the very meaning of async. Luckily, Nathaniel could make this change without breaking compatibility, because when Yuri first implemented that giant hook, he marked it provisional. He said, I'm not sure this is a good feature. So asyncio users know not to rely on it, so Nathaniel can replace it after some consideration. We can learn from this too. If we're not sure that a creature wants a feature, we can mark it experimental. So if we think that a snake would like horns and a quadruple forked tongue, but we haven't actually asked it, we can just offer these features provisionally. If it says, after all, I didn't want the horns, but the tongue's great, you can delete one and mark the other official in the next release. Even if you obey all these 4 covenants, there may still come a time when your creature has a feature and it's official and you need to delete it. Let's say you've got a lizard, it's got legs and feet with these spindly little toes, and you want to transform it into a sleek, modern Python. There's a couple of reasons that you might delete a feature like this. One of them is just that it turns out to be a bad idea, like that funny quirk with midnight. The other thing that can happen is changes in the ecology. So a feature might have been a good idea originally, but then something else changes. The Python language changes, libraries that you interact with change. Like, let's say that some other deity invents something like a fuzzy, tasty mammal, and they live in narrow holes. In order to squeeze into that hole and eat the tasty mammal filling, your creature has got to lose the legs. So how do you do this? How do you prepare the creature to update its lifestyle in response to a chance body like this? So let's say, well, actually, let me first show you this standard library example where something like that happens. So asyncio has coroutines that can run concurrently, and therefore it has a lock object to protect shared data. And you can acquire the lock with this await expression. Then you do something holding the lock, and finally you release it. Now, in the latest Python, we've got the async with expression. This is way better because you can enter a scope while holding the lock, and then when you leave the scope, you will definitely release it, even if this is a complicated function with lots of exception handling logic. So this is more concise and less error prone. But the old syntax is still around. What should we do with it? Well, it's more error prone, and also the Zen of Python says that there should be one and preferably only one obvious way to do it, so this stuff has to go. It's an example of something that had been a good idea at the time, but then the language itself changes and makes it a bad idea. So if we want to make a change like this, we have to think, like, what are the pros and cons of actually deleting the feature after the ecology changes? On the con side, if it requires a huge amount of changes to your user's code, like remember what happened when Python 3 originally removed the U prefix for strings? It was like a nightmare. Or if it requires complex logical changes to users' code, maybe you should just leave it in place. On the other hand, if the change is mechanical, it's just like a search and replace in a function name, or if the feature that you're deleting is really dangerous, that should motivate you to actually go ahead and delete it. So let's say that you've decided that you're going to delete this feature. How do you go about it? To begin with, you've got a reptile that can walk. And you want it to slither instead so it can fit into mammal burrows and eat them. What do? Do you just go ahead and replace one method with another? The problem, obviously, is that you've got users who rely on your code already, and they're used to calling this walk method, and so that's an error now. So you can avoid hurting your users this way by obeying this covenant to delete features gently. How do you do this? There's a couple of steps. You have to go gradually. The first one is that you implement both of the methods side by side, and then you deprecate the old one by raising a deprecation warning. The warnings module is actually really powerful and interesting. I'm not going to talk about it very much, but notice that it's got this stack level equals 2 option here. That's a good idea to do. I'll talk about that again in a minute. Once you have added a warning to this method, the first indication that your users have is that PyCharm or any other IDE will render it with a strike through. And the next indication they have that something's changed in your library is obviously when they run their code, they'll see the deprecation warning. It's merely printed to standard error. You can see that the method still completes. It prints step, 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 and the function, the script succeeds. So how are users actually going to test their code and catch deprecations? They want to know that their test will pass if they have no deprecations and fail if it does. So the way to do that is with this, and notice also that there's an instructive error, which tells users how to fix their code. So in order to turn warnings into errors, so you have firm tests, there's this command line option to Python called werror deprecation warning. And if you pass this, then the traceback shows where the code failed, and this warning becomes an exception, and it does not print step, step, step. So this is great. With all of this stuff in place, now you can just delete the slither method, or delete the walk method, and only leave slither in place, right? Not so fast. Consider how your users actually deploy their code. So they probably have a requirements.txt, and it depends on the reptile library, but your users don't know what versions they can depend on. They don't know whether it's safe to upgrade or not. You need to teach them, you need to communicate about the pace of change of your library. So there are 3 more covenants that we keep with our users, and these are all about documenting and communicating about how our library changes. So first of all, the 6th of the 10 covenants is to maintain a changelog. And this changelog's main purpose is to talk about features that have been deprecated or deleted in various versions of your library. So in this example, in version 1.1, I'm introducing slither and deprecating walk, and in version 2, I plan to actually delete the walk method. So I'm picking particular version numbers here. How am I deciding that these should be called 1.1 and 2.0? It's because I pick a version scheme. So there are 2 big mainstream choices here. One is semantic versioning, and the other, which is starting to become more popular, is time-based versioning. And for time-based versioning, the best document I know of is the twisted compatibility policy there. That's really beautifully written. I recommend that you read it whether you plan to follow semver or time-based versioning. But let's say that we've picked semver. That's still overwhelmingly the choice that I would recommend for most libraries. The Python flavor of semver is defined in PEP 440, and in this example, you might release 1.0 with the walk method in place. In some minor version like 1.1, you can deprecate walk and add slither, and then in the next major release, you can finally actually delete the walk method. So your users in their requirements.txt can say that they depend on 1.0 and later, but they won't unintentionally upgrade to 2.0 and risk backwards breaking changes that they're not prepared for yet. But we're still not totally done helping our users out. How do they know how to do all this? How do they know which version scheme you chose? How do they know how to catch deprecation warnings? The final covenant in this documentation category is to maintain an upgrade guide that actually teaches your users how to upgrade their libraries. An example for this reptile library might instruct users how to upgrade to 2.0. So they would, first of all, they'd have to read your changelog to know what features have been deprecated. And then notice here that you're actually showing them that error deprecation warning syntax. I always have to look it up whenever I need it, so put it in your upgrade guide. And instruct them to upgrade to the last minor release in order to be ready to upgrade to the next major. So this I call a bridge release. The bridge release's job is to deprecate everything that will be deleted or changed so that users know that if they can pass all of their tests with this version, that means that they're safe from deprecations. It's kind of like if you're planning on deleting these legs, you need to give the creature a body that just barely has the legs still there. So now we've seen how to add and delete features with methods. The next level of difficulty, I'm going to skip that, is adding parameters. Adding parameters has some gotchas. So let's say that we've added wings to our snake, and now we actually need to give it a way to use them. so far, the only way it can move is it can choose its direction, but it always slithers. So you have to give it an option to either slither or fly. But of course, you can't just add this parameter because there's still user code out there that only passes the one parameter. We can avoid breaking code like this if we follow this covenant to always add parameters compatibly. So the way to add a parameter compatibly is to give it a default value that preserves the old behavior. Over time, as you add parameters, it sort of becomes like a natural history of this function's evolution, where the parameters are listed in the order that you added them, and each has a default value. This is great for users because if they want to accept the default mode of moving, which is slithering, but they want to set the extra sinuous option, they can use a keyword argument to pick just that option and override its default. This is still a little bit dangerous though, because what if a user writes an application like this where they pass positional parameters instead? Maybe I want to delete one of these parameters, like let's say turbo. I haven't heard anybody say turbo in years. Let's delete that. But the problem is that this code, if they upgrade to the next major version, it'll still work, but it's no longer doing what was intended because the positions of the parameters have all shifted. You want to help users avoid this kind of problem and fail very, very loudly. So the first step is to deprecate the turbo parameter before you delete it, of course. And I kind of like this technique where you swap in a sentinel value. It's just some unique, meaningless thing. It's the new default, and that allows you to detect whenever a user is relying on this parameter, so you can show them a warning. Otherwise, you can just set it to the old default and proceed. So this is great. It gives users a warning on standard error, but users might ignore that. They might not read your guide. So a really great feature in Python 3 is this new star syntax. This requires users to pass everything after it as keywords only. So this is now prohibited. Users must pass keyword arguments for everything after the star. This is great, and you could do it in Python 2 as well if you support it. There's no shame in that. There's a technique here where you can accept kwargs and sort of process them, popping off the expected kwargs, adding defaults if the args aren't passed, and then if there's any unexpected kwargs, you raise a type error. The kind of larger message here is that errors should never pass silently, and in fact, they should be very loud because reptiles don't have very good hearing. If your users are prone to using your library in a way that will hurt them when they upgrade a major version, fail very, very loudly. The thing is that you need a lot of foresight here because you can't, once you've released a version of your library, convert positional parameters to keyword only after the fact. That's a compatibility break too. So you need to introduce the star as soon as you start adding parameters. In the asyncio code, you'll see that the library authors had a lot of foresight, and they use the star pervasively, even if there's only one parameter after it, because they know that they can't add it later. All right, so now we've got the final and most difficult challenge, which is changing behavior without changing API. So let's say you've got a rattlesnake. You want to teach it a new behavior, like sidewinding. This is really cool because it's a new way of moving that does not involve any change to its body. How do you accomplish something like this? So we've got our final example from the Python standard library. It's an oldie but a goodie. Once upon a time, the os.stat function gave you file statistics, and in this case, the create time here, that was originally an integer. It's seconds. The core devs wanted to turn it into a float so that they could give you sub-second precision on the create time, but they were worried. What if people are relying on it being an integer? So they added a way to opt in to the new behavior, if you know about it, which is to set stat float times true. That was in Python 2.3. In Python 2.5, they changed the default. And now you get float times by default unless you explicitly say float times false. Years passed, flying cars, hoverboards. Eventually, in Python 3.1, the setting is deprecated, so you should expect it to be deleted. And then just now in Python 3.7, the setting is gone for good. The only thing you can get is floating point times. So you can see that this is kind of like risky. It takes a lot of versions and a lot of, you have to remember to do stuff in the future. So you can do it. You can learn from this example and change behavior gradually. The steps are that you have to add a flag to let users opt into the new behavior. By default, it's false, and you warn if it's false. Then you, in the next major release, swap the default and deprecate the entire flag, and then one more major release after that, you can finally remove the flag. And at the link that I'll share at the end, I'll talk in more detail about all of this. So that's it. You know how to be a responsible creator. You know how to keep all of these promises to your users. And these 10 covenants, they fall into like 3 sort of loose categories. One of them is to evolve very cautiously. Minimize features. Don't add anything that you aren't sure of. And create features that are narrowly scoped to the problem you're trying to solve. And if you're not sure about them, mark them provisional or experimental, so people know that they might change. Maintain your natural history very rigorously. Choose a version scheme. It's like a language for talking about the pace of a library's change, and write an upgrade guide and maintain a changelog. And finally, change gradually and very, very loudly. So delete features very gently with a deprecation cycle. Add parameters compatibly, use deprecation cycles for them, and use the star syntax as soon as you start adding parameters that you know might change in the future. And if you change behavior without changing API, do that very slowly over 2 major version bumps. So here is the promised link. That's a written version of everything I've said today. It's got links to more information, and it also tells you where to get the cool Python drawings that I used. I'm not going to take any questions, but I'd love to talk to you about this stuff afterwards. Thanks a lot.